Good morning, folks, and welcome back to LNG Academy Episode 2. Today we're going to discuss Prelude LNG, the world's largest floating LNG facility. I'd like to welcome back my co-host Mehdy. Ça va, Mehdy?
Je vais très bien, Alex, merci.
Très bien, très bien. So, Mehdy, let's start talking about Prelude LNG. Can you give us a few numbers about Prelude LNG?
Yes, so where do we start? With close to 500 meters long, Prelude is not only the largest floating LNG facility in operations, but it is also the largest offshore facility ever built. We are talking about more than 260,000 tons of steel for the displacement of more than 6 large aircraft carriers. The construction started in 2012 with the EPC led by Technip and Samsung. The vessel was positioned offshore Australia in December 2017, while the initial production started in 2018, 1 year after. The first cargo was loaded in June 2019. Prelude has a 3.6 million tons per annum production capacity of LNG using Shell dual mixed refrigerant technology, the DMR process. The Nuovo Pignone MR compressors are driven by GE 60 megawatt steam turbines, and power for the facility is provided by 3 Mitsubishi steam turbines with an output of 40 megawatt each. The seven Kawasaki boilers installed on Prelude are also the largest ever built for marine operations. As you can see, an all-steam configuration, which was a key design selection from Shell, but also a choice heavily debated within the industry.
Now, Mehdy, do you think going full steam, pun intended, was a wrong decision?
Well, at the time of the project inception, the technical requirements of a floating facility the size of Prelude were far beyond the limits of offshore knowledge. And I am sure that the designers went through extensive analysis and modeling over years before deciding on the final configuration. Of course, there were also economical requirements that needed to be considered. But judging from the initial cost per ton of LNG produced, the project was on the right track, at least initially. At that time, the FLNG technology was considered an important milestone for the industry to help reduce the cost of developing LNG projects and unlock stranded gas assets. Not necessarily true, as we have seen later. As for steam turbines, and in contrast to the gas types, steam turbines have higher reliability in terms of maintenance. They can run over a wider range of speed, and they are not impacted by changes in ambient temperature like the gas turbines. So you also eliminate the high pressure piping needed for the fuel gas systems, a bonus for offshore facilities. So no, I would say that Prelude troubles are not the result of the steam turbine configuration per se, for both the compression and the power generation. It is true that there were some integration issues between the steam turbines, the generators, and other systems on the facility. But I've heard that those issues were sorted out in 2020.
Excellent. Well, Prelude, we've heard a lot about it over the years. It's made the news several times, not always for good reasons. Mehdy, can you let us know a little bit why?
Yeah, unfortunately that's true. So a series of incidents contributed to the general perception of the project as having technical and operational difficulties. We have seen extended shutdown periods, problem with the offshore regulator in Australia, the NOPSEMA, as well as a pay dispute with the powerful trade unions leading to lengthy strikes. Certainly not the expected outcome for a $17 billion facility. And Shell LNG flagship has been suffering massive cost overruns. It is true that similar large-scale LNG projects have not been faring better too in terms of capex.
So not just technical issues that affected it. Okay.
Yes.
Would you say, from a technical point of view, the main issue has been the power generation package?
Well, the first serious problem encountered by Prelude was concerned about the integrity of the mooring lines. Back in 2019, and before the loading of the very first cargo, the facility was shut down after it was discovered that the steel mooring lines were wearing faster than expected and raising concerns about the stability of the floating structure. It took several months to procure and replace all 16 mooring lines, a period during which Shell was ordered by the offshore regulator, NOPSEMA, to delay the startup of the facility until June 2019.
Okay, I see. And what about the electrical issues on board that we've been hearing about?
Yes. Several incidents were recorded during the first year of operation, including loss of containment reports. However, the very first major electrical trip happened on February 2020. The backup diesel generators for essential power could not be started, posing a serious health and safety risk to the personnel on board. Prelude was shut down for 11 months as a result. After investigation, the offshore regulator, NOPSEMA, concluded that Shell safety management system on board Prelude, the SMS system, was deficient. Also, while most of the subsea wells were shut in as a result, the facility kept flaring a considerable amount of gas during that period. Again, in December 2021, after the detection of a small fire and smoke, a manual total emergency, an ESD1 shutdown was decided, followed by EDP, emergency depressurization. With no gas available to feed the boilers and generate steam, Prelude experienced a total loss of power, followed by the failure to restore it despite multiple attempts over several days to start the 3 emergency diesel generators that have a combined output of 23 megawatts. This is for essential power. The staff was evacuated by helicopters and boats because of the degraded living conditions on board. So everything went down. Lighting, communication systems, HVAC, potable water, even sewage system. We have also the loss of heat tracing to prevent the cooling of the steel structures in the vicinity of the LNG tanks, which is a potential catastrophic scenario. So a main power plant trip, although a rare occurrence, can happen in any LNG facility, but a loss of plant air followed by backup emergency system failure is an extremely serious incident. You also don't want your emergency shutdown or depressurization systems running on batteries that will last for a few hours only. The offshore regulator concluded at that time that the operator, Shell, did not have a sufficient understanding of the risks of the power system on the facility, including failure mechanisms, interdependencies, and recovery. Shell was also asked to demonstrate that the facility can safely recover essential power and associated essential services following a loss of power, and that the safety systems and essential support system operate to maintain the safety of the personnel on board. That shutdown lasted for 4 months. From July to September 2022 last year, production was again disrupted by a workers' union strike. And most recently, in December 2022, and after roughly 2 months of heavy maintenance, the production was again suspended for several weeks, following a fire inside the turbine enclosure and pending investigation. Another major setback for the operator. While we don't have the exact details of these issues and the solutions implemented by Shell, because they're not publicly available, there are still significant challenges for the Prelude LNG project. There are also some minor incidents that were not reported because they didn't have a major impact on the overall operation of the facility, but they are still worth mentioning. The complicated blowdown model, some control and shutdown valves not designed for cryogenic service, and the corrosion issues on the deluge valve for the firewater system.
Wow. That's quite a long list, Mehdy. But I just want to circle back. What was the issue with the emergency diesel generators?
Yeah, that was one of the most significant issues. So I couldn't find any official report, but from what I've heard from the inside the industry, that a high bearing temperature resulting from an excessive load tripped one EDG, one generator, and upon trip the load was automatically transferred to the other EDG, and that one could not sustain the excessive load as well, leading to a loss of emergency power. The high bearing temperature was attributed to a restricted cooling water flow. I suppose that the issue was rectified during the long maintenance period.
Okay, well, we heard a lot there. In conclusion, what can we say about this so far? Prelude LNG, is it a success or failure?
While Shell has never revealed the exact capex of the vessel, it has also never revealed the operational cost of its floating LNG experiment. In 2020, Goldman Sachs said that the Prelude was the world's most expensive new LNG project, at 4 times the cost of LNG produced by Qatargas, which is the leader in terms of pricing. Having a $17 billion facility unable to reach nameplate capacity over extended periods, while global LNG prices have reached an all-time high, is becoming a serious headache for Shell and the shareholders of the project. We have Korean KOGAS, Japanese INPEX, and Taiwanese CPC. Still, the giant vessel is considered by many a marvel of engineering, which I agree. And Shell continues to believe that in the long-term viability of the project. Last year, the go-ahead was given for the $2.5 billion development for the Crux gas fields to backfill Prelude starting from 2027. Prelude has demonstrated the potential risk associated with large-scale floating LNG and the importance, I believe, of having robust safety systems in place to protect workers and minimize the impact of incident on all offshore facilities. I'm sure that many lessons learned from Prelude were incorporated by Technip, the EPC contractor, into the design of its little sister, Eni Coral LNG.
And I think that's the key word you said, lessons learned. And being an entrepreneur myself, I don't look at these things sometimes as failures, but opportunities to learn. So I'm sure that the operator learned quite a bit. We know the opportunity for floating LNG is there, and we're seeing now reports for the Leviathan LNG project, which would be maybe even bigger than Prelude from what I'm hearing. But I think you're absolutely right. The lessons learned here will carry on, and that's really the objective of today's episode, is to really unpack some of these lessons learned for the greater LNG technical community. So thank you, Mehdy. That was a very in-depth analysis, and I hope the audience also saw the value in today's episode today. And we want to thank you, everyone, for your time to tune in. And thank you very much, and look out for episode 3. Thank you.
You're welcome.